Welcome back to Detection Dispatch, the podcast where we get pretty loud and passionate about detection, logic, and overall about keeping SecOps sane. This week's episode, it couldn't be better timed out. I was telling John about it. I just landed back in Chicago from RSA 2025, where every booth, just walking through the show floor, every single booth had agentic AI just splattered all over it and was just pushing like alert triage, 100% automation of every single alert, like it's supposed to cure the burnout, right, that we're facing on the day to day. And I want to get very real about the fact that impact, right, really starts at the root, and that root is your detection logic, right? So while everybody is chasing auto remediation, full alert triage dreams, here on Dispatch, we want to bring it back to reality, right? Because your detection quality starts at the source. And if your logic is broken, or what we'll be talking about today, over-engineered in the first place, you're going to have some serious downstream impacts and not good ones, right? So today we are zooming in on 5 signs that you might be overcomplicating your detection logic, seeing performance bottlenecks, logic sprawls, right? Alerts that are getting shrugged off by your team. And joining me today is someone who knows how to spot false positives and also rare hummingbirds in the wild. John Dempsey. He is a photographer, bird watcher, and detection logic whisperer. And you and me, John, we're going to be false positive therapists today. So, and this episode is going to be a little bit part detection therapy, part reality check. So, John, thank you so much for joining us on the podcast today. Why don't you tell us a little bit about you and how you got into the space, how you made it into cyber, and what you're working on right now?
Yeah, definitely. Thanks, Alex. So for me, I got into cyber basically through kind of your traditional routes of working in help desk systems, administration, engineering, network engineering, and things like that. My
Mm.
first cyber job was actually with an MSP, so working with them in their security engineering unit, basically building out stuff for our clients. And then from there, I've worked in multiple different industries from retail to finance to tech. So my most recent job previous to where I'm at currently was at CrowdStrike, where I was a security engineer in their internal threat intelligence and threat detection engineering team. So basically building out detection logic for CrowdStrike to use with their CSIRT team to detect the threats that they see on a day-to-day basis. And right now I currently work at the National Audubon Society as their senior manager of security operations.
Wow, you walked all of the walks, all the walks, and especially working in an MSSP, you see so many different types of environments and all of the different verticals across financial, all of the different verticals, right? They all have their own spin on detection logic, which is really great. I got to ask, were you there when CrowdStrike had the outage?
I was not.
Oh, I see. I heard the breakdown of how it all went, and I mean I really love how they went about it. I think they went about it in the best way that they possibly could have. But it was so fun hearing a lot of the CrowdStrike folks talking about how they were up all night helping customers through that essentially outage. But I'm glad that so. And now, what are you working on?
So now I'm basically building out the security program at the National Audubon Society, kind of driving the strategy that we have for moving our maturity from, basically the foundation into a
Mhm.
real program, as well as, working on some of the new stuff in the market, as well as what you mentioned, like AI stock, Gen AI, governance, and things of that nature.
Love. And so you've probably seen it all. Like, were you saying, have you seen all sorts of stages of maturity and untangled a bunch of alert complexity spaghetti? You understand what good detection looks like and really what good designs of what good detection design starts and where it starts. And I'm excited to talk about that today with you and just kind of go back and forth and see what you've come across from across these 5 themes and specifically 5 signs that you might be over engineering your detection logic. So starting with the first one, uh, I love actually you gave me this one. When nobody can explain your detection logic, right? When nobody no you write it the first time and it's probably embedded in a couple different parts of your program, but when nobody can explain it, I think you're looking at a real problem there.
Yeah, definitely. I think, one of the biggest things that I've seen across more or the tech-oriented spaces, the SaaS companies and things like that is they're over-engineering their logic to where only maybe the engineer can explain it, and it's only during the time of development. After the development is completed, it's gone through Q&A testing and it's in prod. It's very
Mm,
hard to then go back to that engineer if they're even still there to even
if
ask
they're even
them
still there.
exactly like what was your thinking behind the logic? What do each of these different layers do? It's sometimes not immediately apparent to other engineers what's going on, and then that causes them to have to, back engineer, rethink about what's going on in the logic. And that's
Mhm.
losing time, especially if it's something that's causing a lot of false positives, or if there's an ongoing incident that needs to be triaged and it's related to that detection logic being fired upon. It's really important to be able to just be able to look at something, be able to break it down. Maybe it's commented in the logic exactly which of these lines or which of this layered logic does what. And then that's
Yeah.
easier just for the next engineer or even a junior engineer to be able to come in and perform the work that needs to be done, at that moment.
Yeah, I find this often shows up the most when there's so much nested correlation logic. When you're pulling in from many different places, you're pulling it in maybe from a machine learning feature that is not very that well described, or there's many multiple layers of abstraction, and where it's almost starts to feel kind of like Inception. So the can't stress enough the importance of writing like inline comments, if that's possible, explaining bit by bit what is happening so that anybody can look at it and understand the downstream impacts, right? The rationales, your why behind it. Also, will be cool, come in handy when you tune it. Like if you ever have to tune it, which you'll likely have to.
Yeah, definitely. I think, it's only a beneficial thing to add in. I think the time that's spent on documenting or adding comments to the logic is going to be saved in the event that, somebody needs to reference exactly what's going on here or, add on to the logic and kind of build from there. Refactoring the detection logic is just that much easier if everyone can be able to break down the logic and not have to kind of guess or kind of re-engineer what exactly was going on at that time when that logic was first created.
Right. And this is a good use case too. Like you don't have to, and because people don't often do it, they think it's kind of grunt workish to explain the logic, but this is a great use case for like Gemini or ChatGPT. You just pop it in there and can make a huge difference.
Yeah, definitely. And also just, if you utilize a knowledge base or a wiki or anything like that is going to be definitely helpful in just being a little bit more verbose of, why it was created, what threats it's supposed to be detecting on, or why it was created for a specific type of threat at that time. Just having that context behind it
Yeah,
also goes a long way. Just like we want to have context in the detection logic itself, having the
itself.
context around the logic is the most important part as well.
Absolutely. So context, clarity, comments, rationale, explaining wikis, or if you some coding logic, you can just comment it in there, or some even can add in version history, right? Descriptions of each rule, like if you're saving them in GitHub. So definitely add those. The next one is when your rule is technically accurate, but no one really trusts it. So you probably not so much on over engineering the logic because maybe the logic still works, but every time that it fires, it's like your sock is just sighing.
And I think, the middle part of this, why it's a problem, and, it goes back to our first point is, maybe the SOC doesn't even know why it's firing, right? So they
Hmm.
can't really provide a feedback loop to the detection engineers either as to, what could change, why it's firing so much. They don't have any context to go off of. So it's hard for them to kind of complete that feedback loop for detection engineers to go back, refactor the logic, see where they can make improvements. Maybe there's some sort of suppression logic that needs to be implemented. Maybe something can change to make it of higher fidelity. if you don't have that feedback loop because no one knows why it's firing from the the group that's utilizing that rule to make action on incidents, it's not going to really do any good for anyone.
Yeah, that I think this is uh, completely around how trust is built upon not built upon complexity, but by understanding it right in the first place. Like, why was it even done in the first place, and why is no one feeling confident about responding to it? That it just says sus to me all over.
Yeah,
So,
definitely. I think that if you don't have that type of transparency, you kind of run into this area where there's an expectation that everyone should know how everything works without any explanation. And that
mm,
can put a lot of pressure on, maybe your junior members of your team to feel like they have
sure.
to know everything about all the different alerts that are firing, what the logic does, etc. When you could just have that explained out, it might also potentially have some effect where your junior analysts or other people on the team are providing some ideas potentially because now they're understanding how the system works, how the logic works. They're not trying to guess what's going on in the logic. They have a great understanding of it now, so that could also be of a benefit as well.
I love that you brought that up because that is so true. And that's something we don't think about a lot is this kind of silent everybody should know where we should all be, but over communication is not a bad thing, and that's where everybody can learn, right? There shouldn't be that assumption that you should just know what it means. So, especially for those junior analysts, and also because we're all remote. We're not just sitting. It's not like a back in the day where you could just turn and ask your senior analyst or everybody was sitting together at the SOC. Everyone's all over the place and you can't really learn from them so easily. So the more you over communicate, the better it is for the whole team. I love that you brought that up. I haven't thought about that in a long time.
Yeah, definitely. I think, one thing that I've heard in the past is, there's the mantra of trying harder or to think critically more so than you normally would. I think there's areas where that's beneficial, but when it comes to more of like a team aspect, those kinds of ethoses and methodology don't really work well. If you have a team that you're working with on logic and things like that, it shouldn't be that you need to think more critically or you need to try harder to understand the logic. If somebody built the logic on the team, they should be able to explain it to you and be able to help you understand why the logic is the way it is.
Yeah. I have some concerns for the youth of today because I don't, it's less and less, I feel like every year of thinking critically. They're relying so much on just fast satisfaction, like instant gratification, instant knowledge, like have no patience whatsoever. And I'm really concerned with people's ability to think critically, but I digress. Next one is the alert volume spikes when it does, but you're not really sure why. It kind of has to do with some of the other ones, but it's a little bit different because things can get loud and pretty noisy pretty quickly if you push a rule and it all of a sudden starts to, trigger all of the alarms. And it may not be an over engineering per se because maybe something in your environment has changed, but the over engineering part doesn't account for that when you first make it, right? When you first make it, you make it so specific and you're not accounting for the downstream change that's going to likely happen because it's happening all the time. So it
Yeah,
wasn't
definitely.
made resilient in the first place.
Yeah, no, totally. I see this a lot in environments where maybe they don't have a dev environment that has, the same type of data that they have in their prod environment. So they're
Mm,
kind of trying to test it in prod. Even in dev, sometimes you can test out logic and it looks fine, but maybe there was a data source that was missing that is going to impact your logic differently than it was impacting it in dev. And then, if you don't have a dev environment to work out of, in terms of what you could do instead. Obviously, putting thresholds and things like that are a good idea.
mm,
But also maybe just running it passively, right? Just because you have logic that you feel is going to be great right out of the gate and you can only test it in prod, a better way to
yeah.
do that is probably just run it passively. Don't have it alert on anything. and send that alert to the SOC to review or anything like that. Give it a period of time to kind of QA and prod if you don't have a way to test it outside. And then just kind of see what the metrics look like based on that, kind of gather, what is it firing off of? How can I potentially tune it better based off
Mhm.
of what we're seeing in the real environment? And then once you feel comfortable with it, then you can kind of take your notes, provide it to the SOC, give them that feedback of what you tuned on, what you saw while it was in that passive type mode, and then fully push it to prod and make it active so then it can start alerting the SOC on the high fidelity type of alerts that you were hoping to get from it.
The concept of not having a testing bed or environment is so scary. But
Yeah.
I bet sometimes it's expensive to do that. So I get why you may not have it, but that's pretty wild to not have one, especially when as it relates to tuning. I've also seen organizations have these kind of limiting rule requirements where they would rather not have a rule that fires 5 times a week, right? And that's going to influence the way you're building your rules, right? And if you're planning around arbitrary quotas. But I've seen it done, and that also that also could lead to this over engineering loop.
Yeah, definitely. I think, in a lot of those instances that I've been a part of, it's not a matter of kind of just coming up with these, random numbers that if it fires this amount, we shouldn't make this a production alert or anything like that. It should be rather just, kind of breaking down the detection logic again and understanding what the root cause is as to why it's firing so much and see
Yeah.
what opportunity you have there to tune it rather than just scrapping the entire logic, based on some arbitrary metric like you had mentioned.
Yeah, absolutely. The key takeaway is validation, testing, testing, testing before pushing to prod.
Definitely.
Next one, you're solving for, oh, I like this one a lot. This one, I should have started with this one really. You're solving for edge cases, not the core risk. So you have, I almost kind of see this as like a Tarzan swing moment where you have a clear scenario of what you're trying to do, right? But you are then coding up what like 17 different what if scenarios after that, different 7 different paths that may never even happen because that first scenario is not even clear in the first place.
Yeah. And, to that point, the what if scenarios can lead to a lot of false positives because in those types of instances, you might not have that type of data to even
Mhm.
validate against to see if it's something that is a true scenario. And also, a lot of the times when building out for edge cases, you'll see that there's not really a lot of threat intel going into these edge cases. It could be that
Yeah.
somebody saw something and thinks that it's pertinent to have a detection for, but not really validating whether or not it's relevant to your stack, what you have, your industry, what you're doing on a day-to-day basis, and just writing the logic for the sake of writing the logic, and then
Mhm.
not realizing all the maintenance that comes after that to even maintain something like that. That's another issue that I've seen as well too, based on this.
Yeah, exactly. I like to use the example of like a Serutil execution. It's not just that execution because that can also be used legitimately. But then also the what if that we've tested with is like, what if the attacker renames Serutil for every permutation after that? Or what if a attacker, writes a decode or is looking for an encoded command or and then a decoded command or every single time the process has that call out. That's like five, 6 different layers to catch everything. And I sometimes see that all in one query versus splitting the logic and building multiple rules at a time, which is going to be a lot easier to trust and not necessarily complex. It won't make it complex. Maybe it'll affect the downstream, but that it's going to be easier than just keeping it within one detection rule.
Yeah, definitely. And I think, the behavior-based type detections are the best type of detections to kind of build off of and splitting them apart so you don't have such a large detection logic block to work in. And that just makes it harder to troubleshoot if something breaks within that block, what is broken specifically. But
Yeah.
also, I think that's where we might start to see a lot of the implementations of AI coming in and
Right.
actually making this a lot better in terms of a
Oh,
process where they're pulling in these different data sources, adding that context into that entire stream, and then pulling it
yeah.
all together into just a decision point for an analyst to make, yes, this is relevant, no, this isn't relevant, because it's pulled in the data from all these different sources that you've given it access to, and it's built out that kind of behavior map, if you will, of the detection, how it's grown from inception to where it is now, from when it started ingesting all this data and then making the context and correlation points. And I think that's what's going to be the real strong suit of something within AI being implemented into the SOC and section engineering, is being able to build that out and
Mhm.
then not having these large code blocks or trying to troubleshoot a large, line of automation in times or something like that. It'll all
Mhm.
be right there for you to view. And I think that's something that is going to be the most beneficial in SOCs going forward, rather than some of the more, I guess, popular things that have been said at RSA and other, conventions.
No, but it's true because now it's instead of just looking for every encoded command, you with AI, you can now look for every rare execution of an encoded command, and that already starts to filter it a lot better, or it starts to look for like if the process doesn't normally call for an encoded command, and that's already bringing it a much clearer picture rather than every single static encoded command that's done.
Yeah, definitely. And then it'll help you better understand, just because it was something that was different from normal, or it's a somewhat anomalous or rare event, might not necessarily mean that it's particularly suspicious or even malicious, but at least it's a different data point that it can pull in and then see if there's any other context that it can correlate with that to kind of build out a better picture of exactly why that's a rare event and if it is
Mhm.
potentially something that needs to be looked into. And then that can also lead to less false positives because a lot of times there's detection logic built out for those rare edge cases, but it's something that's changed in the process flow with a different team. Maybe they're doing something different in the
Mhm.
way that they execute a script or something like that. And
Mhm.
having that additional, context is going to be helpful. And I think that's something where AI is going to be able to bring a large benefit to the SOC.
Oh my gosh, so much, so much, so much. That's if we're not already trying that now, I think we're behind, and it's costing us a lot of clarity, and it's costing us a lot of even compute,
Yeah.
even compute. So super good. I love that one. I should have probably started with that one. But last but not certainly least is more of a visual example that around joins, because that's like the biggest ways that you can over engineer your detection logic is to just group a bunch of joins together. And in this example, for our listeners, we are showing something on the screen. Prime example of a suspicious MFA bypass, right? Which is if you're looking at all of these different, about 20, 30 lines of just a recursive join monster. And it starts with a simple MFA failed login, but then it's joined by a series of checks the VPN, right? If it's within the VPN, it checks whether, where are you based, like geo-based distance checks. It checks your travel history. It wants to then after the fact look at the threat intel and risk scoring, and it just looks like a computational failure, because if any of these fail, I guess any of these tables becomes a failure, that's just a failure point, right? It's going to break the whole query just to begin with, right? So instead, what we're saying instead is to focus on one core behavior at a time, which is the failed login in the first place. Because if it's failing in the first place, why do you even care where the geo is coming from? Right? And why do you even care about the enrichment if it failed in the first place? When you reverse engineer the process, it's just a recipe for disaster. So the breakdown of the next one we're showing, like what you should be doing instead, is a much cleaner version, right? That starts from a failed login, right? And then runs the different checks, right? If it's not only a failure, but if the geolocation is not in the selected geolocation from the known user locations, that's when it becomes a little bit more of a higher fidelity alert.
Yeah, definitely. I would say that, that's a lot of what the detection logics kind of starts out as. And then it grows into that monster of a detection that you just shown. It's, a lot of it is, a lot of it comes from the edge cases. and they want to
Mm.
build that into the detection. So they're saying now we got to do this lookup on external Intel sources, or do the lookup on the other table that we have of all the VPN users, or all the users that we flag that should only be in this location. It, it starts to get, untenable, like you had shown, where if any one of those different parts breaks or it isn't up to date, that causes the alert not to function, and then that can cause a gap in your detection. So something like this, keeping it simple, keeping it something to where it's solving for the root reason as to why the whole detection started with in the beginning,
Yeah.
is exactly what a lot of teams need to focus on, rather than over engineering something that started out so simple.
Mhm.
And then again, I think this is where, for maybe the more advanced teams that are looking for something that's more specific than just the failures of MFA logins from, one or two different context, fields, AI is going to probably be able to, again, pull in that additional
Get
context
a
to
lot of,
build out that mapping for your team. So now that you have a
yeah.
more advanced requirement. So like your first example where it's, pulling from different tables or external sources, now that can be built into the AI to do that for you. You can see why it's pulling it, where it's pulling it from, if there's a break in it, and then have that all pulled into just that one incident that it gives to you. I think that's, going to be the most powerful thing moving forward, to kind of build off of these kind of, base detection logics that
Yeah.
more advanced teams are looking for.
Absolutely. That AI is going to change the game for quite literally every use case, every domain individually. But and also now we're seeing more and more, and I saw this a lot at RSA, a lot of startups being able to use agentic AI or pulls from cross domains, because that's really where the enrichment happens, is what is a user doing across different systems and across different like when it spans data platforms, not just within the endpoint, not just what the endpoint agent sees, not just what your identity sees, not just what the cloud trail sees. And I'm very hopeful for the future. But if you're still building, your recursive joins, right? Every every join you do is a potential failure point. You can get advanced with it by constantly doing health checks across these, so that you can keep the rule healthy overall. But overall, keeping the core use case in mind, right? Because you don't need a distance check for a failed login, right? It's nice to have, but that's not the core use case all along. That's just after the fact, right? So
Yeah.
checking the dependencies, right? Instead of, otherwise, you're just going to have to check every single thing to debug everything.
Yeah, and not to mention the performance hit that you have on having to do these external lookups, or even lookups on the
True.
other, joins that you're making. It just, depending on how large that table is and with all the different criteria that it has within it and how you're filtering it in that logic, can cause
Yeah,
a large performance hit on the detection, to always constantly be looking at these different sources that you're asking it to do a check on. So that's another thing to consider, especially if you have a large range of different detection logic that does similar functions. That can put
mhm.
a large strain on your infrastructure from a performance perspective, just having to do all these different things that, is put into the logic.
Totally. And that's what that made me think about, John, is the, and this is a whole other topic. So if you want to come back for another episode on just this topic alone, the scheduling or the staggering of queries. Because you got to think about that too. It's like, because all of these have time parameters, like look back every hour, look back every 2 hours. How are you effectively staggering all of the other queries you have for all the other use cases that you have? That alone is like a job for 10 architects.
Yeah, definitely. I've seen people try to solve for this by building out the automation to update the table in times, and
Ooh,
then having to stagger that based on what the detection logic is doing the lookup on, and making that all align along with all the other types of updates you might be doing to
ooh,
different tables for different detection logics across different, automation for within times, for example. That's a lot to manage. And if something breaks in one place, you sometimes might not know where exactly it was broken, because maybe it's using that same automation across many multiple different detection pieces of logic, and it's going to be hard to kind of pinpoint exactly what's feeding this logic and what's updating that table.
Hmm.
It's really hard, and then that goes back to what we mentioned earlier, is just really documenting the entire process of the detection logic, what's occurring, where are those dependencies located at, how are those
Hmm.
dependencies built. Having that full picture begins to
Totally.
become expansive when you start to do these more complex, detection logic and detection engineering.
That almost seems like a job for like a Kubernetes like node. It's self-optimizing itself. It restarts itself based on a master dependency file. Like that just can we have a Kubernetes of detection scheduling?
Right. Yeah.
Well, that is a wrap. That is a wrap for the 5 signs that you're over engineering your detection logic. Huge thanks to you, John, for bringing the clarity and keeping it real and not letting our own detections gaslight ourselves. Before we go, we have to hit you with our traditional closer. And that is, as a community content creator, what do you love the most of about this detection engineering community? And what do you want to see more of in the space?
Yeah, I love that, the space has a lot of creative people in it that think about how detections can be written and what to look for in a lot of different ways outside of just, the basic stuff that we see on a day-to-day basis. They're very
Mhm.
creative, and I really enjoy that. I think one
Mhm.
of the one things that I'd like to see more is seeing how that creativity can span different things and see what else comes about from their creativity and that they might find to be more impactful in their life than just focusing all of their creative energy into just detection engineering, right? So seeing that, individual maybe growing into something different that they never thought they could be creative in, just because
Yeah,
they put that same energy that they had in detection engineering into something else, and maybe that spawns a whole different thing for them.
a whole different realm. That's what I wish I saw more of at RSA. I feel like everyone is saying the same thing and it's creating a blob.
Yep.
But if we've turned it more towards what you just said, their own energy and their own spin on different realms, maybe everyone wouldn't be talking about the same thing, and it would be a lot more creative, and it would actually bring us closer to what we're really trying to solve in the first place. And detect, which is goes back to detection logic. Like if we don't have the fundamentals right first, there's nothing to automate.
Yep. 100%.
Yeah. So thank you so much, John. Thank you for all of the insights that you brought. You guys can follow John on LinkedIn and on all of his social media. He is breaking down detection rationales and strategies, and maybe even sneaking in a nice nature bird photo, of course, if we're lucky. I haven't seen any on your LinkedIn, but I'm patiently waiting for one.
Yeah, definitely. I will try to get one out every week.
Fantastic. So, listeners, until next time, hope your alerts are lean and your joins are actually logical. And I hope everyone has much needed relaxation time after RSA. Thank you so much.